Hello, namaste to everyone in Gyanmurti channel. Hello, namaste to everyone in Gyanmurti channel. Dear friends, today we are going to discuss about a most important chapter in organic chemistry, that is alcohols. As we know, alcohols are the compounds having the hydroxyl group attached to alkyl group. So, according to definitions here, alcohols are the compounds having general formula, that is ROH, where R represents alkyl group and or substituted alkyl groups, or OH represents hydroxyl groups, which is the derivatives of alkanes in which one or more hydrogen atoms are replaced by hydroxyl groups. As we know the formula of water H2O, in which we can write HOH, and where we replace H, that is hydrogen, from R, that is alkyl group, we get alcohols, the formula of alcohols. Similarly, we have classification of alcohols. There are two bases. One is the basis of the nature of carbon atom bounded to the OH group, and another is the basis of the number of hydroxyl group present in a molecule of the alcohol. As we know, the classification of the base on the basis of the nature of the carbon atom, that is carbon atom having only one OH group, that is hydroxyl group, attached to only one carbon atom, the alcohol is primary alcohol or 1 degree alcohol. Here is the example RCH2OH. Similarly, carbon atom having OH groups is attached to two carbon atoms. That is OH group, that is hydroxyl group, is attached to two carbon atom by replacing the hydrogen atom. Then the alcohol is secondary alcohol, that is 2 degree alcohol, that is R2CHOH is the secondary alcohol or 2 degree alcohol. Similarly, carbon atom having the OH group attached to the three carbon atoms are termed as tertiary alcohols or 3 degree alcohol, where its formula is R3COH. As a figure representing here below, the 1 degree alcohol, 2 degree alcohol and 3 degree alcohol, where hydrogen atom were replaced by alkyl group from 1 degree to 3rd degree. The all the hydrogen atoms attached to the carbon which is bounded with hydroxyl group are replaced by alkyl group. Classification on the basis of the number of hydroxyl groups present in the molecules. As we know, alcohol containing one hydroxyl group in their molecules are monohydric alcohols. Mono means one and hydric means hydroxyl group alcohols. Alcohols containing two hydroxyl groups in their molecules are dihydric alcohols, where di means two and hydric means hydroxyl group. Alcohols containing three hydroxyl groups in their molecules are trihydric alcohols, that is tri means three and hydric means hydroxyl groups. Alcohol containing four or more hydroxyl groups in their molecules are termed as polyhydric alcohols. The molecules of alcohols having more than one hydroxyl groups, each hydroxyl group is attached to different carbon atom, may also be the hydroxyl group containing alcohols. Here another we have, that is Monohydric alcohols. As we know, monohydric alcohols definition, there may be only one hydroxyl group attached to their molecules, and its formula is C small n H 2n plus 1, where n is the number of integers which start from 1 and end up 2. Going soon, so on. Here, it may be a primary or secondary or a tertiary alcohol. As there is a given a figure representing better formula, that is ROH, RCH2OH is a primary alcohol, R2CHOH that is secondary alcohol, R3COH that is tertiary alcohol. And there is example given very easily, we can understand, that is primary alcohol given, secondary alcohol given, tertiary alcohol given as alkyl group in the form here methyl group is attached by replacing hydrogen atoms of the carbon atom which is attached with hydroxyl group. Another we have nomenclature of alcohols. There are mainly common name and iotec name for the classification, which is the nomenclature, not the classification, it is the nomenclature of alcohols or any organic compounds, where one is trivial or common system. In this system, the common name of an alcohol can be obtained by adding the word alcohol after the alkyl group. The common name of an alcohol can be obtained by replacing the ending ane of the parent hydrocarbon, that is parent alkane, by YL and adding the word alcohol thereafter. We get the result, that is alcohol's common name. For example, if we have CH3OH, which is the derivative of methane, that is CH4, then the common name of CH3OH can be written as methane minus ANE plus YL is equals to methyl plus alcohol, that is methyl alcohol. Alcohols containing 3 or more carbon atoms, there can be more than one location of hydroxyl groups. Such alcohols are named as primary, secondary or tertiary alcohols. But here is some prefixes for indicating the naming of the compound, that is yon, iso, yon for normal and iso. Here in this table it is representing the name of the different alcohols with their nature of alkyl group and the carbon atom containing hydroxyl group. Number 1 is CH3 CH2 CH2OH, that is it is in linear form and its name is so normal nature of alkyl group, and its alkyl group is we if we lost OH group and the rest of the portion becomes the alkyl group. And here nature of carbon atom containing hydroxyl group, that is primary, and its common name may be yon propyl alcohol, and its propyl name, as we know that there is a 3 carbon atom representing this normal chain of compound. Similarly, we have CH3 CHOH CH3, that is a carbon atom is attached with two two alkyl group, CH3 group bonded, so its nature of alkyl group is iso and it is secondary, that is 2-degree alcohol, and its common name is isopropyl alcohol as there is 3 carbon atom. Similarly, here is a normal chain compound having 4 carbon atom, so its name is N-butyl alcohol, that is common name or trivial name. Similarly, we have C2H5CH3. Here it is a secondary group or second degree alcohol, so we name it sec butyl alcohol or secondary butyl alcohol. And we have next, that is same the form above, iso group. Here is ch3 2 ch2 group is uh, given in a branched form. So but it is a primary alcohol because it is in linear chain form. And OS group is attached final to its node to the branched part, so it is a primary alcohol. But it is a iso, so its name is isobutyl alcohol. Similarly, we have tertiary alcohols. Iso means the secondary alcohol. Here is little bit mistake, I want to correct this. Iso means secondary alcohol 100%, no doubt. So it is mistake here, it is secondary alcohol. And we have finally our tertiary alcohol. As we know the definition of 3 degree alcohol or tertiary alcohol, the carbon atom consisting of three alkyl group along with hydroxyl group bonded, so it is tertiary alcohol. And its name is tert butyl alcohol, as there is a 4 carbon atom. If we count in, then we get the result, that is it is tertiary butyl alcohol, its common name. Similarly, we have dihydric alcohols. Dihydric alcohols are named as glycols, and they are the derivative derived from the corresponding alkene. Its name, so it that is ethene, and its name is ethylene glycol. Ethyl, ethylene glycol, its name. And finally, our tertiary alcohols. Ethylene glycol is named as it comes from ethine. And here finally we have our tertiary alcohol or 3 degree alcohol because of its source of origin, CH2OS, CHOS, CH2OS. It is termed as glycerol because it is obtained from oils or fats, that is glycerides called its name. We have to remember, and many times they are asked in the entrance exam, competitive exams. Here next we have iotec system. iotec system is an international system, international union of pure and applied chemistry. And here we have some rules and regulations which we have to follow to put name of any particular organic compounds. First of all, the alcohol is obtained by replacing the last e last names e in the name of the parent alkane, alkene or alkyne by the suffix that is ol. As from methane we get CH3OH, that is methanol. And how we can write this name as methane minus E plus OL, that is methanol. For naming higher and branched chain compounds, we should have to proceed the following procedures, that is choose the longest carbon chain containing the hydroxyl group. So first of all we have to choose the longest carbon chain containing the hydroxyl group and identify the parent hydrocarbons. So we have to choose first parent hydrocarbon, then E E in the hydrocarbon is replaced by the suffix ol, that is E later is replaced by ol suffix of the parent hydrocarbon name, and after the position of the side chain and the hydroxyl group are indicated by the numbers that may be in the natural numbers, and here the lowest possible number being given to the hydroxyl group, we have to give the least possible, we can say the lowest possible number for the hydroxyl group. As we have a compound in linear form, we have here in the picture visualized that it is clear that 1 2 3 carbon atom is present, so its name is 1 propanol, propanol 1 or propan 1 ol. Similarly, 2 propanol, propan 2 ol, propanol 2. Similarly, 2 methyl 2 propanol, because it is tertiary alcohol and the previous is the secondary alcohol. Here 2 methyl propanol 2 and 2 methyl propan 2 ol are the correct name of this particular organic compound. Similarly, we have a branched chain compound where we have to give the lowest possible number to the hydroxyl group. So OH group here 3 methyl 2 butanol, and another we have 3 butane 2 ol, as there is the carbon carbon double bond linked in 3 carbon and 4 carbon, and in 2 carbon there is hydroxyl group attached. So 3 butanol 2 or but 3n 2 ol are the correct name of this organic compound. Similarly, we have the table having trivial name and IUPAC name. For monohydric alcohols, we have n-butyl alcohol 1-butanol. The previous example is again repeated here to clarify you all the viewers to get some clearance about this chemical nomenclature. So here another is 6-butyl alcohol 2-butanol. Its IUPAC name as we know above. Similarly, here we have clear viewing that monohydric alcohols, n-butyl alcohol, as we have discussed above, and it is overview to get some better clarification about the nomenclature of this particular organic compounds. N-butyl alcohol 1-butanol, 6-butyl alcohol 2-butanol, tertiary butyl alcohol 2-methyl 2-propanol, as we have discussed earlier. Similarly, isobutyl alcohol, that is 2-methyl 1-propanol, because one carbon is attached to hydroxyl group. Similarly, in dihydric alcohol, we already know about ethylene glycol 1,2-ethane diol is its IUPAC name. We have its new IUPAC name, and we have to be clear because diol here 1 2, because both the carbon are attached and there is 2 carbons, so it n is because there is the carbon carbon single bond, and finally di means there is the 2 hydroxyl group present, and ol is the represent the suffix which we put for hydroxyl group, that is 1,2-ethane diol. Similarly, we have trihydric alcohols, that is glycerol or glycerine. Here the carbon atom is 3 and all of them are attached with hydroxyl group, and so 1 2 3, that is number of 3 carbon atoms all, so prop N is because carbon carbon is bonded with single bond. So propane tri means 3. Here is the 3-OL group, that is hydroxyl group. Similarly, the naming of an alcohol having carbon carbon double bond in its alkyl chain is done in the same way as of carbon carbon single bond. Uh, it would be considered as a derivative of the parent hydrocarbon, that is alkene. For example, we have CH3 CHOH CH double bond CH2. As we have discussed this example in the previous slide, and there we have put its name, and according to iotec rule, that is the choose the longest carbon chain containing the hydroxyl group and identify the parent hydrocarbon. As we focus on this first rule, that is the choose the longest carbon chain containing the hydroxyl group, so we have to choose the longest carbon chain. That is, here we count from starting to ending. We got 1 2 3 4, that is 4 carbon atom is present, and its name is, that is butene. And we have another second option, that is E can be replaced by OL, that is butanol. But third rule, the very important rule, it gives the position of the side chain, and the hydroxyl group are indicated by the numbers, that is lowest possible number being given to the hydroxyl group. So 3 butane 2 ol, because 2 carbon is attached with hydroxyl group, so 3 butane 2 ol. Butane, because third carbon is, we can see here, third carbon is attached with 4 carbon by double bond, so it's 3 butane 2 ol, and 3 butanol 2 or but 3 n 2 ol are the correct name of this organic compound, that is IUPAC name. Similarly, isomerism in alcohols, as we discussed in the as we have learned and discussed, we will later discuss also what is isomerism, but in detail in next lecture. And in this lecture we will clarify about the alcohols isomerism. Chain isomerism means alcohols containing 4 or more carbon atoms exhibit chain isomerism, as the changing the position of the carbon present in the compound gives the chain isomerism. Isomers contain different number of carbon atoms in their chain. So here we have the longer chain length 4 carbon atoms, that is 1 butanol and 2 methyl 1 propanol having 3 carbon atoms, and it is secondary carbon, secondary alcohol. Again we have position isomerism. Alcohols containing 3 or more carbon atoms exhibit position isomerism. It gives the hydroxyl group, that is the functional group, can be attached to different carbon atoms in the carbon chain, and it gives the next certain property, that is the position isomerism. Hydroxyl group have the different locations in the chain. Here we have in position isomerism, 1 propanol and 2 propanol are the isomers of each other, that is position isomers. Similarly, position isomers are 1 butanol and 2 butanol. Similarly, we have functional isomerism. Finally, monohydrate alcohols containing 2 or more carbon atoms solve functional isomerism, that is by changing some of the atom present in um, particular organic compound, we can change its functional group, and it gives the functional isomerism, and it is of the different nature of the organic compound present here in C2H6O represents two compounds. One is alcohol and another is ether. As we visualize this picture, clarifying that there is the one is ethanol, ethyl alcohol, C2H6O, and another is CH3O, CH3, that is O is ether, and its name is methoxymethane or dimethyl ether, because two methyl group are attached to O group, that is O is the functional group of ether representation, and it gives the methoxymethane or dimethyl ether. Thanks for watching this video. Please have any query, then you can comment in this comment box below. Please like, subscribe, share to this Gyanmurti channel. Thank you very much. Have a nice day.